I'm Toby Erickson, a senior electrical engineering student at UM-Dearborn with
Nadim Younes, and I'm also a senior electrical engineering student at UM-Dearborn.
We're going to present our senior design project and the process we went through for the class. And it is wireless charging through magnetic resonance. And our course instructor was Dr. Paul Richardson, who helped us through the entire product development cycle. And then Dr. Azim Hafiz was our team advisor, who helped us with the specific designs and making it through each phase of the design, and also providing resources if we needed additional help. This is all of our group members, and our additional ones, Rami and Zainab.
What we have here is basically what our senior design class consisted of and how that's related to the project lifecycle. So we start with brainstorming and finding an idea, and then the second we are defining our requirements and what that design is going to consist of. Third is going to be the actual design process and putting it together, and finally will be testing. And for us, for now, that's where our design process is going to stop for our senior design. But in most cases, it actually translates over to the launch and then productivity and whatnot. One thing when we were exploring concepts, we really want to focus in on EVs. And as you can see, the pictorial on the left demonstrates how many EV sales are continuously increasing and what companies are selling where and what types and where in the world as well. And then the pictorial on the right is showing that basically every big company you can imagine has some sort of foothold in the EV market. And as time goes on, it's continuously growing. Ford is now teamed up with Tesla to share their EV chargers. And I think this will continue to happen as more and more EVs start rolling out through different companies. Part of our exploration process also consisted of finding an idea for our EV charger. And I think where we got a lot of it from was Witricity. And what they have is a retrofitted wireless charging circuit that you can put on any existing EV circuit now. And we thought, wow, that's a great idea. Let's replicate this. And I think what we really learned in this senior design class was actually we gained a lot of relevance in like how the circuit design process works, magnetic resonance, the state of charge circuit, and also like proper positioning of the vehicle, which is what our design consists of. So for our system prototype, once we've decided and honed in on what we want to do, we actually came over the idea of a magnetic resonance. And with magnetic resonance, we see that it's very similar to how you wirelessly charge a cell phone, except this will allow for greater air gap and distance between your wireless charging circuit, which will allow the user to have more flexibility with how they charge their phone in greater distances. After we've come up with the idea, we now have requirements that we had to create. And part of our requirements is what did we need and how did we need them? And what we came up with is 6 modules. And within each one of these modules is very specific specifications you were trying to follow. And as you'll see is when we go back to testing, we're actually going to match our testing to our requirement to see how well we did in keeping up the design that we chose to go with.
And this is our high-level design system interface block diagram, where we lay out the wireless charging source, the RC car, and then the coils between them that initiate the charging. And then there's also the user interface display, which displays the information of where to position the vehicle and your battery percentage. And these are also all the components required to meet our requirements. This is the low-level design block diagram where we populate the high level with the specific components and the interfaces between them. And also we define the gap between the 2 coils that we wanted to use for the most efficient charging. And for our build phase, we gathered all the components from our low-level design and put them together. As you can see in the slide, we have our sensors, the battery, MOSFET, our coils, the display, and then our garage to hold everything. And also there's a sample of the code that we used in Arduino IDE to program the microcontrollers. And here is a picture of our final build again, showing all of the components in the design.
As you guys can see here is our systems test. And what we did here was actually we took our systems test and we cross-referenced it with our requirements that we had designed earlier to see if our design met our requirements that we've created previously. From that, we created a pass-or-fail system designed on how closely it matched our designs or our requirements through our design. And finally, I'd like to point out 2 of our failures, which were actually the current output and the charge time. The current output was actually limited by a connector that we had between the battery and the charging source. And we actually designed for that. We didn't know that was even going to be an issue until later on in the design. So we just ran with it, unfortunately. And because of that, it limited the amount of current, which also increased the amount of time it would take to charge our battery circuit. But everything else actually did pretty well. Lastly, for our summary, we want to just touch base on what we actually did to complete the entire product development cycle before production, how we actually stayed under our budget of $400. Overall, I think the biggest highlight was our power efficiency, which was 56%. When we compared it to the industry standard, we saw that power efficiency for them was actually 90%, and that came from Witricity. And if you have any questions or concerns, please feel free to reach out to me or Toby Erickson with our emails posted below. And now for the demonstration.
Here's our project setup, where we have the vehicle with the microcontroller on top and the battery in the back and a receiver coil underneath it. And then our wireless charging station has the 3 sensors to position the vehicle and our transmitter coil on the ground. And in the back left, you can see the LCD screen, which will update the driver to properly position the vehicle. And then once it's in position, we'll see the battery percentage displayed. All right, and once we're in proper position, the screen will say distance okay. And then after a little bit, once you can turn off the vehicle, the battery percentage will come up to show your current state of the battery.